Hello again. In this video, we will provide an overview on the diabetes drug metformin, also known as glucophage, and discuss its mechanisms of action. To review, we know that metformin is an oral anti-diabetic drug. It is the first-line defense against type 2 diabetes, and it belongs to the biguanide class. Below is a picture of the structure of metformin. Encircled here is the biguanide functional group of metformin. Note that this is the only drug contained in the biguanide class. Before discussing metformin's mechanisms of action, it is important to have a general understanding of how type 2 diabetes affects glucose homeostasis and just why it's a problem. So let's briefly touch on that. In diabetic patients, insulin sensitivity is decreased because insulin receptors become less sensitized to insulin. So to compensate, the pancreas increases insulin secretion. However, the pancreas cannot sustain elevated insulin secretion for very long, eventually causing the pancreas to secrete less insulin than normal in the long run. In addition, insulin sensitivity remains lowered. Now, due to a decrease in insulin sensitivity and a decreased production of insulin, the cells cannot efficiently uptake glucose to use for energy. Without glucose being able to enter the cells, the body interprets this as an energy deficiency. As a result, glucagon secretion from pancreatic alpha cells ramps up, promoting the hepatic production of glucose by increasing hepatic gluconeogenesis and glycogenolysis. In addition, glucose that is consumed cannot be efficiently taken in by the cells due to the insulin insensitivity. Both of these contribute to increased blood glucose levels, which is the reason for type 2 diabetes. Another way of looking at the type 2 diabetes pathway is understanding the antagonistic relationship between insulin and glucagon. As we noted earlier, when insulin levels decrease, glucagon secretion increases. So, due to the body's inability to secrete insulin in type 2 diabetic patients, alpha cells in the pancreas will increase glucagon secretion. Now that you've gained an understanding on the effects of type 2 diabetes on blood glucose levels, let's move on to its mechanisms of action. Now, metformin has at least 3 different ways in which it works to stabilize blood glucose levels. So let's take a look at the primary way in which metformin exerts its effect. Metformin's primary mechanism is to decrease the glucose-producing processes described earlier. And here's how. When the patient takes metformin, it activates the liver enzyme AMPK, also known as activated protein kinase enzyme. Activation of AMPK then decreases gluconeogenesis and glycogenolysis, thereby leading to a decreased blood glucose level. We will now briefly explain metformin's other 2 hypothesized mechanisms of action. In the second mechanism, metformin increases insulin sensitivity. Recall from earlier that type 2 diabetic patients exhibit a resistance to insulin. Let's take a closer look on how metformin treats this. Metformin sensitizes insulin receptors, labeled here, to insulin by increasing the binding activity between insulin and the insulin receptors. This causes more GLUT4 transporters to appear on the cell surface, allowing more glucose to enter cells. This effect lowers the blood glucose levels. Finally, in the third mechanism, metformin works by decreasing the intestinal reabsorption of glucose. In conclusion, we've discussed metformin's place in therapy as well as its structural properties. We also took a look at the mechanisms of action metformin employs to decrease blood glucose. There are several other oral anti-diabetic drugs, each with their own mechanisms of action, such as Januvia. If you are curious, we encourage you to look to other resources to see their mechanisms. Thank you all for participating. We hope you understand the importance of glucose homeostasis, acquired a general knowledge about type 1 and type 2 diabetes, and can appreciate how drugs like metformin work to stabilize blood glucose level. With this understanding, let's take a look on how this knowledge translates to a patient encounter.